coordinate as a polar coordinate that would produce that exact same point. Okay, whether we can figure that out. So is that doable? Could you come in and give me a r and a theta that would land the point in that same spot?
Yeah, so it'd be negative.
2 and 1/8.
R's the distance.
Yes, r is the distance from the origin to the point, so that would be,
That's still negative
2.
that's still going to be,
Right.
Well, is it?
It's R18 and 2 180.
2 and pi.
okay.
Yeah,
All right, now we know that there are lots of different ways to do it because we know that we talked about that Friday that you could come up with lots of different representations for that point. So it doesn't have to be 2 and pi, but that is one way to do it, right? If we come in with an angle of pi, all right, so here's my angle pi. And then on the terminal side of the angle, which is this side, going 1, 2, places that point in the same spot. Okay? So what I want you to realize is that for any rectangular point that I give you, we should be able to get at a polar point that produces the same dot on the graph. Okay? There's some sort of conversion that can go on between the points, going from rectangular to polar, even from polar to rectangular.
So in that situation, if the R was negative, it would be on 0 angle?
Yes.
In the dotted,
If
okay.
you do it that way, you could say the angle was 0, which would just close it right on top of itself here, and then a negative 2 would count you back to the left. Yes, so you could do it that way as well. All right, everybody okay there?
Okay, wait a minute. -2 is going to go back on the opposite side.
Right, if you plot this one,
It's the same thing as rectangle.
you plot 0, a 0-degree angle is here,
Okay, I get you.
and then the dotted line's going to come back this way.
Okay.
It's going to end up in the same spot. Okay.
Serious stuff.
All right, so the issue here is there's a relationship between the two, okay? That if I give you a rectangular point, you should be able to give me a polar. And we're going to work on that today, but that's what we're dealing with. And if I give you a polar, you should be able to give me a rectangular. Then you can always describe that point in either of the two ways. Okay? All right, so now let's look at this a little bit more. Let's say that I give you the rectangular point 1, 3, okay? And I ask you to give me the polar coordinate for that same point.
Then we'll just draw this, or just think it in our head?
No, we're gonna work it out. Yeah, this is not something I don't think we can do in our head necessarily, because I want you to think about, if you plot out the point 1, 3. Okay, there's your point right there. That's not as easy as what we just did over here, correct? I mean, over here it was fairly easy to deal with. Why? Because it was on the X or Y axis. But when you get off of the X and Y axis, then it gets a little more difficult to deal with because you've got to come up with an angle in here. Okay? Maybe you know it, maybe you don't. And then you've also got to figure out the distance from the origin to the point. So you've got those two things to try to figure out as you're working this. Okay? Now, the book gives us formulas to do this. Let me show them to you. And then let's kind of talk about where they come from. All right, so here on page 326, all right, that's what we're going to look at. Okay, now that first formula, that r squared is equal to x squared plus y squared, all that is the distance formula from algebra, okay? Do you guys remember talking about distance formula in algebra? Okay, that's all that formula is. So they're not coming up with anything great and new here for the trig. They're just saying, because what is the r? The r is going to be the distance from 0, 0 to that point. And so really all they've done here is pull that distance formula that we learned last semester or whenever you took algebra and said, hey, we're going to use that again here. Okay, so that one's really not gonna be a big deal for us, I don't think. All right, and then the other one is going to be y over x, okay, and you're gonna use the tangent. All right, guys, in the back, you guys gotta pay attention here, okay? So what happens here? It's a really tiny picture, but they basically got a triangle drawn in there, okay, and just sort of look at that for a second. When you're drawing that triangle and you're moving from the origin to that point right here, you're going over in an x direction, right? And when you go from the bottom up to the top, you're going up a y distance. Now look at that. If I were to put my angle right here in the corner and ask you to do tangent, you would say tangent is opposite over adjacent. Okay, so that's where that formula is coming from. It's based on the triangle that comes with coming up with that point. Okay, you don't necessarily need to know where the formulas come from, but sometimes I think that's easier to help us remember them rather than just sort of pulling them out of the air. All right, so we're basically using distance formula and then using the right triangle. All right, so let's see what we do when we plug it in. Remember that if you have a rectangular point, you have an x and you have a y. Okay, and so really all you need to do is plug into these two formulas and work it out. All right, so I'll put my x value in, my y value in, and we get 10, which will be the square root of 10 for the r. Plug into the other formula. So y over x. So we need an angle where tangent is equal to 3.
Pi over 6.
All right, and how do we come up with that? Is that something that we know off of our...
The chart.
Yeah, that's not something we know, right? So what's our next best thing if we don't know how to do it? Calculator. Okay, so if it's something that you don't know from your unit circle, we should be putting that thing in the calculator. All right, you're going to find that most of these, the book is putting them in radians. Okay, I don't necessarily know that you have to do that, but if the book's doing that, my guess is that's what my math lab's going to be doing as well. All right, so let's do that. Let's put the mode in radians. All right, just so that we're consistent with what the book is doing. Okay. And then I'm going to do an inverse tangent of 3, okay, to get my angle. And so my angle here would be 1.25. All right, and then you just want to put it together, make it look like a coordinate. R value is square root of 10, the theta value 1.25.
That's it.
And that's it.
So we'll always have to use those formulas.
Yeah, you always use those formulas.
You still do it if the theta is negative, or not?
If the angle is negative,
You still okay with the point? No.
yeah, you'll still, I mean, yeah. Let me show you one more, and then if you still have the question, ask it then. Okay, I think I know what you're asking. All right, so what if our point had been -1, negative square root of 3. Okay, this is my rectangular point. And I want to give polar coordinates. Okay, so why don't you guys just see what you can do with this. It's going to be pretty much the same deal. Work on it a minute and then we'll put it up on the board.
And you don't have to choose the formulas?
You're probably gonna wanna graph it. This is the got it flipped, yeah.
You know where that is? And it's set. 5 or 6. There, 2 over 1/2.
I don't know how to graph that, is that, put that in there?
It's like, put 1 square root of 3 in your calculator to get a decimal for it, and then you'll know where it's at.
What's
It'll be
Negative
1.05.
I was just put negative